When multiplying radicals, you need to follow the multiplication property of radicals, which says that let a and b represent real numbers such that the nth root of a and the nth root of b are both real. Then you can take the nth root of a and the nth root of b when you multiply them and just get the nth root of a times b. So how does that work? So if you have the square root of 25 and the square root of 4, you can just bring them together under one radical and just say 25 times 4, which will give you 100, and if it's possible to simplify, you do. So for ours, we're going to multiply 5 root 3 times 2 root 5. So when you're multiplying radicals, you can only multiply coefficients with each other and radicals with each other, so long as they have the same index. So 5 times 2 is going to give us 10, and then 3 times 5 is going to give us 15. And 15 cannot be broken down, so we leave it as 10 root 15. Now we have square root of 5 distributing into 4 plus 3 root 5. So everything is just going to distribute in, but the same rules still apply. There is an understood 1 here as the coefficient, so we can do 1 times 4, which will give us 4. And since this doesn't have a root, we're just going to say it's root 5. So root 5 times 4 is 4 root 5. And now we're going to do the same thing here again. 5 times 3 root 5. Again, the coefficients of the root 5 and the both of them are 1 and 3. So we're going to have 3 root 25. However, root 5 cannot simplify down, but root 25 can. So we can say that 4 root 5 plus 3 times 5. So 4 root 5 plus 15, and you cannot combine these because they both don't have a square root of 5. So this is the simplified solution. Now we have a bigger one, 2 root 3 minus root 5 times root 3 plus 6 root 5. So again, we're going to distribute, or if you prefer, you can call it foiling. So we're going to do our first 2 root 3 times root 3, which is going to give us 2 root 9. And then we're going to do these two. So that's going to be 12 root 15. And now we're going to do these two. So it's going to be a negative root 15. And now we're going to do these two, which will be a negative 6 root 25. And now we're going to combine what we can, or first off, let's simplify what we can and combine as well. So 2 and root 9, which is just going to be 2 times 3. Both of these have a root 15 and nothing else, so we can say that 12 minus 1 is going to be 11 root 15 minus 6, and square root of 25 is 5. 2 times 3 is 6, plus 11 root 15 minus 30. And now we can combine the 6 and the negative 30, which is going to give us negative 24 plus 11 root 15. And this is the final answer for this expression. Now, there's a little shortcut method if you may have noticed. Square root of 3 times square root of 3 gave me 9, which reduced down to 3. So if you take a square root times itself, it's going to simplify down to just what's inside. Same thing we did with square root of 5 and square root of 5. It simplified down to just 5. So this is a kind of a shortcut if you would like to take it, but if you want to go the way we have been, 100% okay. square root of 2 minus 4 root 3 all squared. Now don't forget that a square just means that there are two of these parentheses. So square root of 2 minus 4 square root of 3 times square root of 2 minus 4 square root of 3. And we're going to do the same thing we did before. We're going to distribute it out. So root 2 times root 2 is going to give me root 4. Root 2 times negative 4 root 3 is going to be negative 4 square root of 6. Then negative 4 root 3 times 2 is going to be negative 4 square root of 6. And then negative 4 root 3 times negative 4 root 3 will be positive 16 root 9. Simplify and combine. So square root of 4 is just 2. The middle two terms I can combine, so negative 8 square root of 6. And then square root of 9 is just going to be a 3. So keep everything as is for now. And I'm going to do 16 times 3, which is going to give me 48. And then 48 and 2 is going to give me 50 minus 8 square root of 6. And I can't combine anymore, so this is the final answer to this expression.